Let's talk about sequences and series in today's lesson. Before we talk about sequences in detail, let's have a look at what different sequences look like. This is an example of a sequence. I have another example which goes like this. There can be one more sequence looking like right. Now, how are these sequences identified if we look at their terms? Before we discuss in detail about how sequences are dealt with, we need to remember some important terms that help us know more about these sequences. The terms that I'm talking about here are finite and infinite. Now, what is the meaning of finite and infinite? If you notice the three sequences here, we know that the terms given in the sequences, the number represent the term in a sequence. So the numbers that you see in each sequence, or the terms that you see in each sequence, have a rule that we can use to find out the next terms in the sequence. We have worked in detail in patterning concepts when we have discussed about patterning. So this is a kind of a pattern that we notice how the numbers are increasing. So that's pretty simple. I can see the numbers in this sequence are each time increasing by a 1. So once I have got the pattern rule, I will say this pattern comprises of all the terms that start with a 1 and go on increasing by 1 each time. So if I have to find out the next term, that's simple, that will also be increasing by adding 1 to the previous term. The difference in these sequences that I want you to focus on is through finite and infinite sequences. Finite represents something that have a fixed value, whereas infinite is something that doesn't have a fixed value, or it goes on, or it cannot be counted. So over here, if we see there's three sequences, the first sequence has been shown after 5 or after 6. You can see there are certain dots that indicate the sequence, the number 1, is ongoing. It is not ending here or here. Even if you find out the next term, it still has many more terms to find out. That means there is no end to this sequence. Whereas sequence number 2 and sequence number 3, if you notice, 10 and 18 are respectively the last terms of these sequences. You don't see any dots that indicate the sequence is still going on. So we stop at 10 and 18, and that's the end of the sequence. That means the finite sequences are sequence number 2 and sequence number 3, as they have a fixed number of terms, while sequence number 1 doesn't seem to have any end over here, as the dots show the continuation in finding the terms. That represents infinite sequence. One more important concept that you would have noticed, as I just indicated, that the terms in the first sequence were increasing by 1. The terms in the second sequence are all increasing by 2 each time, while in the next case, the terms are increasing by a 3 each time. It's not that all the terms are only increasing by adding a positive number. It can also take place like if I start with -9, and I have a -8, and I have a -7, and I have a -6. So the sequences can have negative terms as well. Now, how much am I adding to this term to get the next term? In this case, this is also a 1. Sometimes if I go in a reverse order, and if I make a sequence like going from -6 to -7 to -8 to -9, the terms are increasing. But how much would you add to -6 to make the next term -7? Yes, it would be a -1. Then you add a -1 again and you get the next term, -8. So over here, if you notice, the sequences can increase either by adding a positive number or by adding a negative number. This is an important concept to remember, how the terms are related to each other. Another important concept to work on sequences is how to find out the terms when you know one term of the sequence. If there are some missing terms, how can you find the terms when you know some values? For example, let's say my second case of 2, 4, 6, 8, and 10. And let's make this an infinite sequence so we can calculate some of the missing values that will be coming after 10. To do so, we have to remember a term that's called general term. Now, the general term denotes the formula that you can use to find out any missing term in a sequence. There are a few requirements for that. For example, the first term tells me that my sequence is going to begin with a certain number, and that is represented as A. So the A represents the first term of my sequence. The second important thing to notice here is by what number are the terms changing each time. As you see here, the terms are changing by a 2 each time. So the number by which the terms are changing each time is called the common difference. That's noted by D, and that's common difference. I'm writing the short form here, right? So if I say my first term was an A and my second term was increased because I added some number to that was a D, I get a simple formula to calculate. If my first term was an A, my second term was D more. That means it was A plus D. Going to my third term, it was 2 more than my second term. That means I have A plus D plus 1 more D. So this was my second term, and I added another D to it. And going further, my third term increased by 1 more D gives me the fourth term. So if we try and describe this as first term, second term, third term, and it's my plus, and the fourth term. Here, I notice that I'm always adding 1 extra D to the previous term that I know. So my general term formula is knowing the first term and adding D's to it, which depends on what number of term you're finding. If you're finding the first term, you don't need any D. But if you're finding a second term, you need 1 D. That means second term needs just 1 D, which represents the term number -1. So if I'm finding the second term, I want to find out 2 minus 1 D's. So that's here, A plus 2 minus 1 times D. And if you simplify the bracket, you will get, it gives me A plus 1 times D. And if you notice, this was the formula for finding my second term. So even without I knew this formula to calculate the general term, I could find out my second term just by adding a D. How? This formula helps in finding some terms that may be difficult to find out just by adding 2 each time and continuing the sequence. Let's see that. So if I just follow the same sequence and using the same general term formula, I want to find out a specific term of the sequence. Let's say I want to find out the 20th term. of this sequence, I have to remember some values that I can give to all the alphabets given in the general term. What are those numbers and what are those values? So for this sequence, if I say I want to find out the 20th term, for which I need to know the A, and my A is 2, the first term. By what number are my terms increasing each time? My terms are increasing by a 2 each time, so that's the common difference. I want to find out the 20th term, so my number of term is 20. Right? Now, to calculate the 20th term, I use the general term formula. I say N20, or you can simply say 20th term equals the first term plus the 20th term minus 1, that's 20 minus 1, times the common difference. And when you open the bracket and you multiply, it makes 19 times 2. Now using BEDMAS, multiplication first and then adding. So we have 2 plus 38 adding to 40. That means the 20th term in this sequence should be 40.